These questions are just practice, extra practice, but mixed up with the vertex and find the root. So for word problems, what you're trying to understand and picture what you're given. So what is given and what's being asked, like what you're trying to find. Remember, vertex or max-min questions mean you find the vertex. So when I mean find the vertex, that's the one where I would say vertex x, or you can do x with a little v there, is going to be the negative b over 2a, or you add the two roots, divide by 2, right? So, or, etc. So I'll put etc. So however you find the vertex. But that's the vertex question. So if it says max-min, right, or find the vertex, you're finding this. If I just say find the roots or find the integers, then you're not finding the vertex. You've got to know the difference between the two types of questions, right? So that's what this sheet's about. So if I say to you, oh, and for these ones, we're just going to set up the intro sentence, the let statement, and then the equation, and then we're going to state if we're finding the vertex or the root. Like, would I do quadratic formula or factor, or would I do this, right? So we won't go ahead and do the whole solving, but let's set it up, the starting part. So when I have the sum of the squares of two consecutive integers is 761, find the integers. Is this a vertex question? No, right? So not a vertex. So we're going to use either solve, so not vertex, so not, okay? And then contrast that to the next one. And again, we'll set them up. Two integers have a difference of 8. Find the integers if their product is a minimum. So both of them say find the integers, because sometimes people go, oh, so when I find the integers, I'm solving quadratic. No, it's not those words. Which words is it? This one says that the sum equals 761 and nothing else. This one says they have a difference of 8. Find the integers if the product is a minimum. So this part here is telling you it's a vertex question. So that tells me we need to find the vertex. So when we solve this one, I'd be using vertex x equals negative b over 2a or any of the vertex methods. For this one, you're finding it by using probably factor or the quadratic formula. Does that make sense? So factor or quadratic formula. So when I set them up, look at how the setups are a little bit different. So the sum of the squares of two consecutive integers is 761. Find the integers. So let x and x plus 1 represent the consecutive integers, right? Then we want the sum of the squares, and it is 761, like it actually equals it. There's nothing missing. So it solidly is there. So that's why I would use the factoring and bring it over to 0 and just solve for the x's. No vertex on this one. For the next one, so to contrast, two integers have a difference of 8. So I might say let x and y represent the integers. We know that x minus y equals 8, and then their product is a minimum. So, so their product is xy. So when I solve for this one, right, so I bring, so maybe the y over, or I'll bring, yeah, so x, I'll bring this over, x minus 8 equals y. When I sub that in, I'm going to get, look, there's no number, right? That's when we're going to find the vertex x. There's no number that it equals. So see how this is different? This one, I'm telling you, they actually total to 761, period. Right? We're not finding max-min. This one, I'm finding the product that's maximum. So this is the one where I would bring it together, or you can use the two factors and do the vertex x. So I would maybe do x squared minus 8x, and then xv, or vertex x, which is negative b over 2a. Does that make sense? So to see how they're different, they look almost the same. They're integer questions, all that stuff. So they're still integers and all that in terms of the setup, but one of them tells you what it equals, and one of them is telling you to maximize or minimize that product or the sum or whatever it is. Okay? So see the difference between them? So it can be an integer question, but they're two different ways of solving it. One of them's missing what it equals. This one, it says it equals 8, but then when you put it into the product, it's missing the product part. Right? This one, it is just solidly 761, nothing else. So you're solving for this one. Okay. Good, the contrast? Right, so when you decide, so look at the next one. I have a school eco club, so I'll read it because I know it's small. The school eco club is designing a garden for school. The garden is to measure 20 by 14 meters. There's a uniform, so this word uniform border, they like to use this uniform border. It's like a frame, and the reason why it's uniform is because it makes your life a little bit easier. So if this frame around it was two different widths, you'd actually have a much more complicated equation. But because this frame, we call it a frame or a border question, right? So this part here, so they're saying that this, here to here, those are all the same. So that's what they mean by uniform. So that's x, the distance between here and here. So this is x as well, that's distance is there. So the distance between, can you see that little diagram? Right, so this distance here, those are all little x's. So the distance between the inside and the outside, so the border. Yeah?
For a frame question, will it always be in the middle like that?
No, good question. That's what I was just going to say. So look, the garden is 20 by 14. I can either give you the inside garden or I can give you the outside dimensions, right? So I can vary the question by saying the outside of the garden is 20 by 14 and I want you to go inside. Or I can say the inside part of the garden is 20 by 14. I want you to make it bigger. So which one did I give you in this case? 20 by 14. There's around the garden. Yes, so 20 by 14 is the whole garden, and there needs to be a border of rocks around it. So I gave you, the whole garden is to measure 20, right, 20 by 14. And then we're putting rocks on the inside to put a rock border on the inside. So that means the inside part. So this inside part, so that's why they love to give the inside or the outside. So the inside is going to be 20, but you took two little bits away. So this inside dimension is going to be 20 minus the 2x, right, for this side. And then for this side here, that side is going to be 14 minus 2x. Does that make sense? So the inside part of this garden, so this part here, I'm going to color it green, right? That part there is the inside portion. So it's 20, but I took 2 bits away, and it's 14, but I took 2 bits away. Yes?
Is it minus 2x because, like, there's an x on both sides, if you get what I mean? Like,
yes, there's an x on both sides. Sometimes they'll say, so there was a couple in the homework where they put it right into the corner, didn't they? They said, okay, but I want the border to be only on one side, so they did this. And they said, no, but I want it only to be on one side. So then the x was here, and the x was here. So it was only be, so if that was the case, it'd be 20 plus x, right, to get bigger. Or if I was saying 20 is the outside, to go inside, you go 20 minus x, right? So you decide if it's the outside dimensions I gave you or the inside. So it's either plus or the minus. Is that good? Yeah.
If all dimensions that are inside are the x's, does that mean they're all the same?
Yeah, so all of these, I should have made this bigger. I'm sorry that it's so small. So let me just redo this one. So it's this. I'll make it a bit bigger. Sorry, I forgot it was so small. So then this, they're saying that it's like if you're doing a frame of a picture, these are all X. So these are all X. Uniform. So that's what the word uniform means. Yes, so this is saying they're all X. Right? If they don't do it uniform, it makes the question more complicated because you have to set it up different. Like it would be harder to do. So that's why they keep saying uniform. Those borders are all the same. Is that okay? It's a little bit bigger? Okay, and then again, if they say it's 20, the whole garden, then this is 20 minus 2x. And then this side here, for this dimension here, that would be 14 minus 2x because the outside. Yes? Because look, if this is 20 and I took these 2 bits off, how much should I take off? So the arrow goes from here to here, right? But I'm saying cut this off and cut this off. How much did I cut off? 2 x's. So it's 20 minus 2 x's. And then the 14 was the outside here. But then how much did I cut off? So the arrow goes to the corners. I cut off this and this. How much did I cut off? 2 x's, yeah. So then that's why the inside now is 14 minus 2x. Yes, yeah. So you're not given the, you're given the outside dimensions, the 20 and the 14 is the out. So you're looking for the inside.
So how do we, now how like with the 20 minus 2 and 14 minus 2, how do we calculate the, how do we calculate the area? Do we do like,
Okay, can you wait? I'm going to do the rest of the question. We're not done yet, right? So we're just doing the diagram. Okay, so that's okay for the diagram. So I either give you, frequently we give you either the outside and you're making it smaller, or we give you the, say the inside is that and we're making a border outside of the garden, right? So if I said the inside garden is 20 by 14 and we're making a border outside of the garden, you would add 2x. Okay, so that's how we get that diagram. So we're good for that. Now, there's always going to be something to do with how much the area is. So, and they can vary how they give you this part. So here, the garden is 20 by 14. There's a uniform, so that makes sense, the uniform, right? X, X, X all around. So uniform means the same X's around the garden. If it's, that is half the area of the garden. So now, do we know how much the garden is? How much is the whole garden? The EcoSub is designing a garden for school. The garden is measured 24 around the garden. That is half the area of the garden. So the garden is to measure 20 by 40. Uniform around the garden. Wait, is this outside or inside? The garden is to measure 20 by 14. And there's a uniform border box around the garden.
I think it's outside.
I think it's outside. You just read that, right? So
it's plus 2x.
yeah, it is plus 2x. Yay. Okay, good. So let's do the diagram again. So this is good practice, right? So when you read it again, right, making mistakes is how we learn. It's actually really good. So it's good, good, good. So then we go one more time. So we're going to make the diagram even better this time. Now I'm going to make it a little bit better. My markers are ready. Okay. Okay, so one more time. The garden is 20 by 14. There's a uniform border of rocks around the garden. Ah, so read that again. So then we go, okay, so the garden, so again, it's still uniform border. I'm going to make it nice and big, so hopefully you can read it a bit better. So it's going to be like this. Okay, so the garden is 20 by 14. That's the inside. Then we're doing the uniform border around. So these are all X. You can just do tick marks if you want. Some people say, oh, it's that easier if I can just do tick, so they're all the same. Tick, X, X, X all the way around. So you can go X and they're all the same. Some people like the arrow, some people like the tick marks. So that's X around. So that I want rocks around it. Beautiful. Okay. So 20 by 14 inside. So then, okay, so now we've practiced this a few times. What's the outside? If we know these are all X's, right? X here, add an X here, add an X here. If I have 20 on the inside and I'm adding 2 bits, 2 X's to it, then the outside part is 20 plus 2X to go corner to corner. Yes? All right, and then this here would be 14. So 14 here, but I'm adding 2 sides to it, so 14 plus 2X to go corner to corner. Okay, and again, sometimes they'll say at one side only, so the border is only on one side. So that's when we would do a single X versus a double X. Okay, and there's a couple homework questions like that as well. Make sense? All right, so we're either going inside or outside, so we're given the border or not. Okay, and we've got that. Now, this border, so this border here, the garden is going to be this part here. So I'm just shading that in a little. So this part here is the garden. So that's the inside. I know that the garden here is 20 by 14. So I have the area of the little shaded part. The outside part is half of this area. Do I know what that area is, the one that I just shaded? Right, this area is how much? 20 by 14, right? We know the area of a rectangle. So we know this is 20 by 14 in the inside. If this is half of it, what's half of 20 by 14? That's 140. That makes sense? So this part here is 140, half of the inside. So the border is 140 meters squared, meters. The inside we know is 20 by 14. True? Right? So this is 140 meters squared for this outside part here. Yes? This I'll do dash pinks here. Good? The inside part is 20 by 14. So 20 by 14, so that's going to be 280 meters squared. Good? What's the area of the whole thing? 280 plus 140. Does that make sense? Because it says that's half, so we know that the pink part here is 140. We know that that's 280, so that's half of that. All together, so I'm going to say whoops, zoom out a little. Okay, we're going to let X represent the measure of the uniform width. I kind of use the words that are here, okay? Then we're going to set up your equation. Your equation usually just uses the area of the rectangle. There's more than one way to do it. I find that you guys like to just say, okay, what's the whole rectangle here? So you know that the whole rectangle is going to be 20 plus 2x times 14 plus 2x. Does that make sense? This and this, length times width, doesn't matter the order. And we know that it equals, how much does it equal? 280 plus 140. So 280 plus 140, so in my brain I go 280 plus 140, which would be 420? Is that right? 1, 2, 3, 420. So I know it equals 420 altogether, because the pink border here is 140 meters squared. The green part inside here is 280. Together it's 420. Is this a vertex question?
No.
Not a vertex. We're not maxing. We're just finding. We know exactly what it equals. No vertex. Right? So then this is not a vertex. So not a vertex question. So we go ahead and use quadratic formula or factor, etc. Any questions? Yeah. We're finding how much we have to add to each side so that it totals properly. So we know that the inside is 14 by 20, right? How much do we want to go outside to make sure that the whole area equals 420? So you're trying to find this measure here, the X. It's not always going to be like a nice number. Like I can't just add 2 to each side because that would make it 14 plus 2, 18 by 24, and then you have to keep going back and forth. Like you want to use this quadratic to find the actual measure so it equals it exactly, yeah.
Okay, so we found the area of the outside, right, which is like 20 times 2x times 14 times plus 2x.
Yep, we know that the total area, yeah.
And that would give us the area, which is 420. But how would that be the measure of the uniform width?
It's not that 420 is not the measure of the uniform width. X is the measure. So when I solve for X, I'm finding how much I had to add to each side so that when I multiply those two numbers together, when I go 20 plus 2x times 14 plus 2x, I'm going to get 420 back.
Wait, have we finished the question?
No. Yeah, so we haven't finished. So one more time. I said I'm not going to finish the questions. We're going to set them up. And I don't have the answer. I just made these up so we could learn how to do the setup and decide which question was which. So to finish this one up, we would not do vertex. We would use quadratic formula probably, right? Unless you can factor it by bringing it over. I don't know if this is a factorable number, so I'd probably go to quadratic formula, and you're going to get your X numbers. From your X numbers, you might get a negative, you might get a positive, then you decide from there. So these are setup questions. I'm just trying to practice the setup. Okay, so we're not done, but we would solve for x and find the x. Sometimes we get two x's. One of them is going to be silly, like a negative, like no way. One of them might be too big, like if it's like 20, can I cut 20s? No, I can't. I can't cut two 20s out because the side's only 14, right? So there might be a silly answer where it's not possible, and then a good answer, right? So then you go through that. Okay, yeah.
Can I ask how do you get 140?
140? Oh, half of 280. So it says here, the rock garden is half, this pink here is half of this. If I know that this is 14 by 20, then I know that this will be 140. So 140 plus 280, the total area. Okay? All right, so let's set up another one. So look at the next one. We're going to say, okay, a magazine producer can sell 500 of her magazines at 12 each. A marketing survey shows that for every $3 she increases in price, she'll lose 25 sales. What price should she set to obtain greatest income? Greatest income is telling me that this is a max-min question, right? So this is a vertex question, so vertex. So when I solve this, I'll do vertex X or, the midpoint of the vertex, that sort of thing. So greatest income. So we need that. So when we set this up, we're going to do I usually did this, let X represent the number of $3 increases. I think we had this on our quiz, and I think a lot of people use this. Didn't we have this one? Okay. Then we said we were going to do the number, so I usually did the number times the amount. You didn't have to show this, but it's the number of magazines I sold times the amount would give me my revenue. So my revenue is how much you earn, revenue. So the number, and then yes, right, we highlighted, and we did two different highlighters. So we said 500 of our magazines, yes, I saw a lot of people do this, would lose 25 sales. So those go together. Sorry, my highlighters died. So 500 of her sales. Can I do this? Oh, that's brighter. She will lose 25. Okay, and then in the yellow, this was the $3 increase at 12, right? So we put the money together. So make sure you don't mess it up. People did the highlighting, but then you put them backwards. So this money goes with this money. So we know it's $12, and it's increasing an unknown number of times. That's why the X goes with the 3, because we're going to do 3, 3, 3, 3. So you highlight it, now keep them together. So this is the money one, okay? So keep them separate. Then this one here, oh, sorry, I have it backwards on my, fix that. So I did the money one first. It doesn't matter the order you do it on, but this one's my money, right? So remember, that's the money one that you grabbed here. So grab only the money. Don't flip that around. Right, you're highlighting the right stuff and then you're flipping it around. So here, the magazines is going to be this blue one here, and that is going to be the number. Right, so then from this one we said, okay, the number is 500 magazines minus 25x, and that's going to change. So that's my blue. Right, so keep them separate. You got them, you got the right idea. And then you would do the vertex. So I think most people expand it and then do the vertex X, but it's up to you, right? You have the two roots, you could do that way. We have the 3 methods of solving it, right? A lot of people like the vertex X thing. Okay, so then you find the vertex.